Oh, beautiful. So as you can see, the last time when we solved this equation, okay, let's go and have a look at the equation. Okay, the equation we solved was 1 over x cubed plus x squared integral dx. So when we went through all the processes, okay, the first one when I solved, or when we did together, we realized that our final answer to the first approach was negative half. Okay, that is this negative negative half here, natural log of 1 plus x squared raised to the power negative 2 all into bracket plus c. So that was the answer for the first methodology or approach. Okay, then somebody made an assumption that the first method is more compressed and a bit difficult to his understanding. So we came to consensus that we are going to apply the traditional approach. And the traditional approach in this sense is a partial fraction. Beautiful, partial fraction. Okay, so we followed every process and eventually we got our values of A, B, and C. We substituted into the equation. Okay, then we got to this place where we say negative half integral of delta u over u is the same as, since we know since we know that when we integrate 1 over u is the natural log of u. So our answer eventually got down to this. So this was the second approach, the partial fraction approach. Here. So there's a fraction, the answer to, let's say partial fraction, let's say partial PA approach. Okay, so this partial fraction approach. Beautiful. So that is what we got. Then we said that the first equation. So we call the first equation the left hand side. That's it. This is the first equation, and this second equation. Well, by inspection, when the people came back to me, they told me that they don't think the two answers are the same. Just because the first answer, after calculation, we saw that is minus half natural log of 1 plus x raised to the power negative 2 plus c. Okay, so by observation, you see, the reason why people are saying that is that this is 1 plus square raised to the power negative 2. And the partial fraction method, we had natural log, that is this one. Okay, we had natural log of x minus half into bracket x squared plus 1 plus c. And people are saying that because of the absolute value of x here, okay, and also here the x is x raised to the power negative 2, and this one is x squared plus 1. So this is x raised to the power negative 2 plus 1, and this okay, so I told them that why don't they substitute in some values into the equation and check, where people were not amazed by that. So today we are going to explain the reason why it is so. So let's in the first place consider working from the left hand side to prove that it's the same on the right hand side. So if that is the case, so our left hand side, let me go back to the right. Our left hand side, our answer we had as is written over there. The answer we have, the answer we had, as you can see, is minus half natural log of 1 plus x raised to the power negative 2 plus c. Okay, this, I think we can still write this one as minus 2 natural, minus half natural log 1 plus 1 over x squared plus c. Okay, then when we simplify, we say minus half natural log all over x squared plus 1 all over x squared plus c once again. Is it not beautiful? So, look at it. But, we know that if we have log to the base 10a plus that of log to the base b is equals to a log the product of ab. Okay? And then if you remember this, we also know that if we have log of a minus log of b, then it's going to be log, yeah, a divided by log b. Okay? In the same way, this principle or properties also applies to natural logs. So, natural log of a, okay, natural log of a, okay, minus natural log of b, okay, will give us natural log of a over natural log of b, which is same as the natural log of a over b. Okay, now let's apply. Let's start from here. That's what we have at the moment. Okay, so if we expand this, then you will see that from here we will see that we'll bring the minus half out, all into bracket. This will be natural log of s squared plus 1 minus natural log of s squared, all into bracket. Okay, now let us look at it. This, once again, we can say, minus half into bracket, this is natural log of x squared plus 1 into bracket. This is 2 natural log of x into bracket. Okay, so when we expand, when we multiply through by negative half, then we are going to get negative half expansion, natural log of x squared plus 1. Okay, and negative half multiplied by that's plus natural log of absolute value of x. Bear in mind, maybe somebody will ask me, why this? Why this? Okay, let me explain that if we have natural log of something like a squared, this can be written as 2 natural log of a. Yeah, this is a simple property of logarithm. So our equation can be rewritten by saying the natural log, bringing the natural log of absolute value of x out. Okay, minus half natural log of x squared plus 1. Hence the proof. Okay, hence the proof. Okay, yeah. Okay, hence the proof. Or we say QED. So eventually, if we look at how we started it from the left hand side, see everything we've done, we tackled the left hand side and we've calculated it. Now let's compare this equation over here. That's I've marked it with green here to the right hand side of the equation. So let's go up there and see. You see, so we have natural log of x, natural log of absolute value of x minus half natural log of x squared plus 1. Let's go and up there and see. Check our final answer. Look at it. Yes, here we are. It's the same. Okay, the c is just a constant. Yeah, we add to it. So we can add the c to it, which is the constant that we attribute to it. Because, yeah, so plus c. That's it. Well, thank you very much. I hope this explanation makes sense. Thank you very much for coming. And we're looking forward to see you again. But please go down there and like the tutorial and also subscribe so that will motivate us to do more. Have a nice day. Bye.